Yes, we're back with problem 6.2. Hopefully you've got problem 2.2 figured out. Problem 6.2, the main question here really is quite a bit simpler. It's just what's cheaper, leasing or buying? The question didn't really say how much cheaper, although we're going to look at that. So it potentially makes the statistics easy. You could really just deal with this proportion question. Once we start looking at it, we'll see. Would you stop waving at them when I'm trying to talk to them? Sorry, they like me better than you. They're not really watching you anyway. They're watching me anyway, so you just sit here. Okay. We're going to see it gets a little deeper than that. So, as before, we've really got two options in this problem. We had you're going to lease it and then buy it at the end of the lease, or you're just going to buy it. Either way, you plan on keeping the car. And we also had the other option that if you lease it, you're giving it back, or if you buy it, you're selling it in 2 years. So I've kind of pre-done the if you're keeping it anyway, which is the longer problem here. So we have the trials, and we hinted at this. The calculation really isn't that hard. I'm going to do the F2 here so you can see it. We count how often does it say less versus how many times did we do this. And it tells us that it's about 50% of the time, which makes it kind of a half and half situation. So maybe you do want to look at the actual distribution. So I did the 5-number summary again. It's a kind of an interesting 5-number summary. The minimum, the smallest value to the 75th percentile. So the 75% smallest values are jammed in essentially between $42,000 and $46,000. It's a very small group for 75% of the values. Then, wow, boom, up there on the high end. And that's not some weird fluke. If you hit F9, you'll see about this. In fact, it's even wider, but you see about the same. The min in the third quartile are still in the same range, and this shoots way up there. Why, oh, why does that happen? Don't be such a drama cat, Stat. It's not that big of a deal. You just were trying to get screen time. Yeah, I was. It goes back to this decision right here. Doesn't look like it here because it's got the weird formula, but we use an exponential distribution to simulate the number of miles driven. And by nature, the exponential distribution usually bunches up by small numbers and occasionally has really extremely high numbers. So you're almost guaranteed that the mileage driven was going to be skewed with a very long, unusual, but very long, far out there high miles tail. And whenever the mileage gets extremely large, we had 106,000, and then we do it a little slower, see if we can get a big number like that again. There we go, 57,000. It has a big hit on the cost, and therefore the net present value of leasing the car. So out of 500 trials, yep, we see some really wide ones. So to kind of reinforce that, I checked the mean. I didn't necessarily plan to do all of these. If that hadn't come out near 50-50, I may not have done these. If I hadn't seen that, I may not have done this. But that does confirm that it is skewed to the high end, but in spite of those very, very high ends, there can't be a lot of them out there if the mean and the median are actually that close. It's a question about sample size again. So I went through a similar calculation on if this is my point estimate for what's the probability it's cheaper to lease with 500 values, and I want 95% confidence, so these formulas are the same as the last one. %, I typed it in. Again, this is essentially the alpha over 2 notation. So 1 minus 0.95 is alpha, divided by 2 is 2.5% in each tail. That tells me the z is 1.96. The margin of error calculation is a little bit different. It doesn't look like the algebra statement from an algebra class, but it's the z times the square root of the entire thing here. Your point estimate times 1 minus your point estimate divided by your sample size. And if I'm sitting at, in this case, 45%, but anywhere near no, 54%, anywhere near this 50-50, cheaper to buy, cheaper to lease, the 4.5% margin of error kind of bothers me now, because that's 4.5% either way. So I'm going to, in this case, go back to my original problem and say 500 wasn't enough. So I'm going to delete the table that I put in here and redo it with 1,000 trials and see what that gives me. So I'm redoing my many trials part. Remember, it just copies those values down because I did my settings so I don't have the constant auto recalc. So I have to hit F9 to get a recalculation. And that's still a pretty big margin of error. I'm still getting about 50-50. For now, I won't go any bigger because it's going to bog other things down too much. So 3% margin of error one way or the other, which is pretty typical with a sample size of 1,000. And it's about a 50-50 proposition. The one that you will download off of Schoology actually already is 1,000, but I wanted you to see me go from 500 to 1,000 on this. I'm going to probably leave it 500 on the next one. So for now, I'm not going to do the actual histograms. I may do that in the next one with the different histogram method, but I want you to see this part set up. So here we're going to dump it. If we buy it for $43,240, we're going to sell it in 2 years. And if we lease it, we simply lease it. So the question still is leasing then cheaper than buying? And of course, it depends again a lot on the miles driven. Remember, the miles were exponential. Yes, remember the miles were exponential. So they got this part started. You already have this because I gave it to you that way. I'm not going to go step through step for putting those into here that you have over here. I will let you do that. So pause the video for just a second and copy or mimic those formulas over in here so you have the correct output for this particular problem. Of course, now the question is, what are you doing? Do you just want the lease, or now do you want the buy-sell? Because the buy-sell present value is changing. One difference here was that when you bought it and kept it, then the present value of buying it and keeping it was simply that number. It never changed. If you buy it and dump it, well, now the present value changes because what you get for it changes also based on how many miles you drive. So you may need to do a little more calculation here than you did on the first one. But let's pause it and see what you can do. Did you pause like you were supposed to? I'm sure they paused like they are supposed to. I don't trust them. I trust them. They paused like they are supposed to. Okay, well, let's look at your answers. It's fine. We'll look at mine now. We had seen previously, since we hinted at the statistics actually in the multi-trial portion of this whole thing, that if you're going to get rid of it one way or another, the probability lease is less is really small. I left the 500 here. I decided not to do this one as 1,000 because this probability is so small. The margin of error is also quite small. When it comes down to, there's a very small chance that you're going to save money by leasing. Well, so what does that mean? Well, let's look at the actual cost in the distribution. At every point, from the minimum to the first quartile, to the median, to the third quartile, until we get to the max, but for these, in every case, buying it and then selling it in 2 years is lower than leasing it and giving it back. Same for the mean. Oddly, the max is the one place, so like your worst case scenario is where it says, oh, you know, you'd have been better off just leasing it and giving it back. That's, of course, where this 1 and 2% seems to come from. So we could make a histogram, and I thought about it. I think I'll do a histogram in the next example instead. You might want to do one here. It's up to you, just to see if you can figure out how to do one. But this does kind of show the distribution, and except for the upper tail, it's clearly going to be cheaper to buy it and more expensive to lease it. Again, if you're going to keep it anyway, these numbers aren't here, but remember the present value B17. There's no variability here. So you would do this. That'd be the comparison for lease it, buy it at the end of the lease, or just buy it and keep it, for that matter. That's why we didn't do the calculations there and didn't include them here. And you'd have to decide this top 25% risk, how much risk that is. So I won't tell you whether you should buy or lease the car. That's a different decision. Our simulation is to give you the information to make that decision. Now, take a pause again, look at this one, and then go on to the next problem.